Welcome to the CAD Office Training Guide series for FDOTConnect. I'm Nathan Myers, Assistant BIM Technician and Structural Engineer at WSP USA. Today I'll be going through the Open Bridge Modeler Training Volume 1, Introduction to Model-Centric Design. In this series of videos, we'll take you step by step through each exercise from the guide. In this session, we will complete the last exercise of Chapter 5, which will walk through the creation of an approach slab. Let's begin. So before we dig into exercise 5.4, let's take a look at what the end product should look like. So as we can see in the view windows here, we have added the approach slab onto the bridge that we've completed thus far through exercises 5.1 through 5.3. So we have our main span we've already created with the deck, barriers, substructure, and the beams are underneath there. So from here, we're going to create our approach slab, which is shown here. The approach slab is going to be made very similarly to how we did the rest of the bridge, where we just create the deck, we add the superelevation, and then we'll put the barriers on top of it. However, there are a few different differences that we need to account for. One would be the asphalt overlay that's going to go on to the first 28 feet of the approach slab. So this portion right here is actually lowered 1.75 inches lower than the rest of the deck. So there's a little jump here from the first 28 feet of the approach slab to the last 2 feet, and then that is the same as the rest. We also have to account for that difference in our barriers as well. So our barriers are going to be a little bit taller, so the base of the barrier is going to be 1.75 inches taller, which can be seen in the difference between one of the main span barriers and this approach slab barrier. So we have a specific template for those that I'll be showing you how to incorporate into your model as we get into it. Something else to point out is how this section of the bridge is created. So you have the option, if you would like, to either add it as a separate bridge in the model or as a additional unit within a bridge model that you've already created. So if we wanted to, we could make it have it considered as a completely separate bridge that just happens to be right next to the one that we already created, or we can just add it to this structure as a separate unit within the bridge. And I'll show you how that's organized in the Explorer. So if we come up to our Home tab, Primary Group, and the Explorer tool, and click on that to open that up. So then we can come down to our Open Bridge model. So this, as we break this down, we'll describe all the different components of our entire model and what is inside of them. So the whole bridge model can be broken down to get to the bridges. So if we add the approach slab as a separate bridge, like we actually do in this exercise, it will be added as a separate bridge underneath this category. Now if we break one of these down, so say we take the main span bridge and break it down further, we see that there are units within that bridge. So we already have the one unit for what we had done in exercise 5.1 through 5.3, but if we had added this approach slab as a new unit, like we could choose up here, it would show up within this category. So the Model Explorer is a good way to investigate your structure just to see what is there. It's a good way to find things that for some reason are not showing up right, just make sure that they are actually there. So if we break this unit down further, we see all of the components that we've already created. So we created, the decks, the beam layout, beam groups, so on and so forth, which can be seen, in the model. So if I select this barrier, the barrier shows up in the model. So the same goes for all these different components. So what we're going to do within our approach slab, what we're considering as a new bridge, is we're just going to create the deck and the barriers for this approach slab. So with that being said, let's get into modeling. So now I have brought up the exercise 5.4 begin file, which picks us up right where we left off in exercise 5.3, creating those substructure components. So we can see here. So now we're going to add our approach slab within a new container. So let's go up to add bridge. We want to make sure that these inputs are correct for description. Should follow this. We want it to be a reinforced concrete slab bridge type. We want to have the bridge decorations feature definition. Now let's change this name prefix to approach start. So now, since we added it as a new bridge, we're going to have to reselect the bridge alignment that we want. So it's going to be the same center line of construction that we selected for the other part of the bridge. So let's left click on the proper alignment. Left click again to enter the bridge data. And now we've created our approach slab bridge. Now you can't see it obviously, but we've just created that container within the Explorer tab. So now we have to create our support lines for our bridge. Now we're not creating any substructure components, so it's not going to be actual support, but it's going to determine the breaks in our deck, because we have that first 28 feet of the slab is going to be recessed slightly to accommodate for the concrete overlay or the asphalt overlay. And then the last 2 feet are going to follow the same elevation as the rest of the deck. So let's add those support lines by going up to the Home tab, the support line group, and we're going to go into Place, Multi. So there's a few ways to do these inputs. We just want to make sure that our start station is correct so that we can modify the rest of them in the next window. So let's modify this to 341. Plus 73.53. So that's going to be the location of our first support line. We're going to want 3 support lines just to separate those 2 portions of the deck. And let's make sure that our feature definition is support line. So I'm just going to left click here just to open up the next window. Had to left click a few times just to input all those. So now we have to really modify these support lines to what we want. So we want the first span to be 28 feet. So there's going to be 28 feet between the first and second support line. And then we're going to change our second span to be 2 feet long. The support lines, 2 spans, and we'll click OK to input those. So you can see they've been placed into the model. And then we can right click to exit this Place Multi-Line dialog box. So now we have our support lines. So now that we have our support lines in, we can start to actually input our deck into the model for our approach slab. So like I said before, there are 2 separate slabs that are going to have to be placed. One for the 28 feet of deck that will be just 1 3/4 inches below the main span. And there's going to be a section that will be at the same height as the main deck slab that will be around 2 feet long. So let's start with the 28-foot span, and then we'll make all our modifications to it, and then we'll come back and do the last 2 feet afterwards. So we can start making our deck by going up to our Home tab, Superstructure group, and Place Deck. So let's make sure we have the right template name in, which Slab with Constraints. That looks right. We want to have that negative 32 feet of horizontal offset. And let's change this vertical offset to negative 0 feet, 1.75 inches. And we want our deck material to be the approach slab concrete. So if I open this ellipsis, we'll be able to see all of our options. So within our concrete material, we can just go down alphabetically to approach slab concrete. And there it is. Select. We want our slab. And we can just keep the name prefix as deck. So now we want to select the support lines for this deck. So we want to pick the first support line that we just created and the second one. You can see them being highlighted in the view 2 on the right as well as I pan over it. Left click. And it's placed. Now obviously it's not to the right dimensions or super elevation that we want yet, but we'll be making those changes here in the next few steps. So to update the super elevation, we're going to have to repeat the steps that we did in exercise 5.1 to assign the super elevation. So first, let's turn on the super elevation file. Let's right click at this place deck window. Let's go up to our references. And we have our super elevation reference. Let's turn that on just so we can see it. Now we can see that in the model. Go our assign super elevation tool. Now we are prompted to select the super elevation section. So we can do that, just left click on it. And we'll right click to reset to complete. I'm going to select our deck as the candidate. Now we'll open up this super elevation assignment window. And similar to the exercise 5.1, we're going to make a few changes here. So we're going to change the template point of the second row to 0.5. Change our pivot point of the second row to 0.0. And then change our template point back to 0.1. We'll hit OK. We're okay with that, so let's just hit yes. And now the super elevation has been updated. So now let's modify the deck to match the lane widths and the thickness that we desire. So if we just hover over the deck, pull up the variable constraints by going into properties and selecting the ellipsis for variable constraints, which opens up this variable constraints window. So let's change our thickness first. So we'll come down to the thickness, select that variable, and activate it. And we'll hit the plus sign to add a row that we can modify. And we'll change the start and end value of the deck thickness to -1 foot for both of them. -1. We make sure that it's for the full interval of the first 20 feet, which it looks like it is. So let's go to our left width next, and we'll activate that. Add a row. And we want this to be -23.5417 feet, or 23 feet, 6.5 inches. Again, we have the right interval length, so we can follow up with changing the right width. Hit the activate. We'll change this to have a start and end value of 31.5417. 31.5417. If you were to input it directly as 31 feet 6.5 inches, that would be correct as well. When we put in a decimal, that decimal had been rounded from the 31 feet 6.5 inches, so that's why it would have been slightly different if I were to type in the rounded decimal here and the exact inch value over here, but it would only be different by whatever the rounding cutoff would have been. So we have all of our values in correctly. We changed our width and we changed our thickness, and our you'll notice that the slope has already been input. That's what the assign elevation did for us, is it changed this variable constraint for the left slope and the right slope to match the super elevation that was in the file already. So we can hit OK to assign those variable constraints, and there's our first segment of the deck. So now we're going to do the same thing for the second section, for that last 2 feet. You can see this gap here, which will be filled in by the second deck piece. I'll put that in quickly, and I'll show you the end result. It's the same steps as creating this first section. So we place deck. We do not want the vertical offset, so 0. Approach slab, deck material is correct, features definition is correct, template name is correct. And we want to select our deck boundaries. We want to pick the second and third support line. And we'll left click to continue. Again, it's incorrect, so let's go to our assign super elevation. Right click out of there. Assign super elevation. Select the super elevation section. Reset to complete. Select that deck component. Template point is changed. Pivot point changed. Template point back to point 1. That's okay. Now let's change our variable constraints. The only thing different here for these variable constraints from the last section that we just did will be the thickness. So the thickness is going to be slightly different. It's going to be negative 1.1458 feet. 1.58. Negative 1.1458. Our left width is going to be negative 23.5417. Negative 23.5417. And the right width, make sure that's activated. Add a row. 31.5417. 31.5417. And all our variable constraints are correct. Hit OK. Now our deck looks correct. We have the 28-foot span that's just a little bit lower, and we have our 2-foot span that matches the elevation of our main span deck. So the last components we have to add to the bridge before we have completed this exercise will be the barriers. So remember from exercise 5.2, there is a template. In this case, we're going to be using the F-type 32-inch barrier. So there is a left and right barrier template that's selected, and each of those templates has a working point, which is going to match a point on the deck. So if you see this screenshot of the deck placement, so this is what we're going to be adding to our approach slab. So we had to create a special template for the approach slabs that will accommodate for that different deck elevation. So we have those designated as the Flex AP barrier templates. So we have our F-shape L for the left side flex AP and the F-shape R flex AP. Now remember that 2-foot piece will be matching the rest of the deck, so those sections will be using the just a regular F-shape L, so that it will match up perfectly with the rest of the deck. So ideally we're going to have a smooth elevation. So the elevation for the top of the barrier will be continuous the whole way across. So there shouldn't be any jumps going from the 28-foot section of the approach slab to the 2-foot section of the slab, and then into the main span of the bridge. So let's go ahead and start placing those. We're going to start with the left flex AP. We'll go to the left regular, and the right flex AP, and then the right regular. So we can go over to our home tab, over to accessory, and then place barrier. So for our left template, so like I said, we're going to go and use our F-shape L flex AP first. You see there's a slight difference between the two. This line here is a little bit taller for the flex AP variant. So I flip between them. So let's select the flex AP and hit select. And we'll select our candidate, which is going to be the 28-foot section of our slab. We want the horizontal offset to be positive 1 foot 6.5 inches. And then when we're placing the right barrier, we're going to want that to be negative 1 foot 6.5 inches. Make sure the material is correct. We want that deck concrete. And we want the feature definition to be traffic railing. So we have the candidate selected. We can right click to end that selection. And we'll left click to open up this path selection window. Go to our guidelines. So this is what's matching up our working point of the barrier with a position on the deck template. So for the left side, we want it to be the 0.5. Okay. Make sure that box is checked, and we'll hit OK. And that barrier is created. So let's do that again. We'll change it to the F-shape L regular. So now we want to change our template back to the F-shape L. Hit select. Now we'll select our candidate as that 2-foot section at the end of our approach slab. So we'll left click on that and make sure it's highlighted, and we'll right click to end that selection, and then left click to open up the path selection window. We want the 0.5, which is that left top edge of our deck. Make sure that box is checked so that we have selected an alignment. Hit OK. And our barrier is placed in. And we can see it has a smooth transition between the barriers. So that means that we input it correctly. So we're going to repeat those steps for the right side of the approach slab. Again, place barrier. Change our template to the F-shape R flex AP. Select. Remember, this is going to be placed on the right side, so we're going to have to change this horizontal offset to negative 1 foot 6.5 inches. And now you want to make sure that before you actually place this barrier or select any candidates or anything, just tab out of that box just to make sure that that input has been appropriately recognized by the program. Because if you change it but you don't enter it by exiting that box, it won't actually recognize it as a change. So we've done that, and we want to select our 28-foot section of the approach slab. Right click, left click. We want to select a different point because we're on the right edge. We want to pick this point 1. That's up here. OK. And OK again. And the barrier's in. And last but not least, we'll do the F-shape R regular. Select the 2-foot section. Right click, left click, select point 1 again. OK, OK, and it's in. Again, we have that smooth transition between our barriers. So that is it for exercise 5.1. Thank you for joining me today for the CAD Office series for FDOTConnect. This was exercise 5.4 for the OBM Intro to Model-Centric Design Guide. In the next video, we will follow exercise 6.1 to create structural drawings of our model.